All right, so we're looking at the quadratic formula, which is going to allow us to find the zeros, roots, or x-intercepts of any quadratic that we're given, and especially helpful when it's not easily factorable. So this will work with any quadratic, although it is more complex than just than solving a simple trinomial by the short method we've been using, but it will work in when you're in a pinch and have no idea how to find those pair of numbers that work in a given situation. So if you're given an equation in the form of y equals ax squared plus bx plus c, you can use the equation x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a. That will give you the x-intercepts. Note the plus minus means that there is two answers here. There's one where we're going to add the square root portion to negative b, and there's one situation where we'll subtract the square root portion from negative b. This also occurs, and it's important to note, when the y value here equals 0. Okay, so we're looking at this in the case where y equals 0. So I got some examples here that we'll go through. It seems like a complex formula, but it's not really. It's just a matter of filling in some numbers. Once you get the numbers filled in, if you follow the process of bed mass, then you should be quite good with it. So here's my equation. I got 6x squared minus 1x minus 15. I did put the negative 1, and I actually put the 1 there just so that you see it, but normally you would just have a negative x, and you'd assume that the b value would be 1, in this case negative 1. So I'm going to fill in that formula above. So I have x equals negative b. b is negative 1. The negative 1 is positive 1. Positive 1 plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 6, times c, which is negative 15. All that is over 2 times a, or 2 times 6. So now I just go step by step, simplifying this using bedmass. I'm going to start under the radical here and work with the first portion. We have negative 1 squared, which is just 1. And then I have negative 4 times 6, which is negative 24. Negative 24 times negative 15 is going to be positive 360. All that's over 12. Because 2 times 6 is 12. Now I can take that addition under the radical there. So positive 1 plus or minus the square root of 361 over 12. Now I can take the square root of 361, and that's going to leave me with 19. It's going to also leave us in a predicament where we have to separate this. We can't do anything else. We can't divide by 12 until we do the addition on top of the divisor line. So we have to do 1 plus 19 and 1 minus 19. So we're going to break this up into two components now. So once we get to this step here, we need to break this up into two. 1 plus 19 over 12. Or the other possibility is that it is 1 minus 19 over 12. 1 plus 19 is 20 over 12. And I'm just going to finish that side off. That's going to give me 5 over 3 when I simplify it. And then in the other situation here, we have x equals negative 18 over 12, or x equals negative 3 over 2. Those are the two possible solutions. So it's those two. Those would be the roots of my equation when y is equal to 0. Now in the next case, we're given y equals x plus 4 squared plus 5. So this is in vertex form. So we can't fill in A, B, and C because we have an A of 1 here, but we don't have a B and a C value. We have an H and a K. So we need to expand this out. So x plus 4 is a perfect square trinomial. So that's just going to give me x squared plus 4 times 2 is 8x plus 16, and then the plus 5 at the end. We'll add those last two, y equals x squared plus 8x plus 21. Now I have this in proper form. I can even put the 0 in there because we're finding the zeros or x-intercepts in this case. Now I sub in these values, a, b, and c, into the quadratic equation. So x equals negative b, or negative 8, plus or minus the square root of b squared, 8 squared, minus 4 times a, which is 1, times c, which is 21. All over 2 times a, again, which is 1. So now if I simplify that down, negative 8 plus or minus the square root of 8 times 8 is 64. Negative 4 times 1 is negative 4. Negative 4 times 21 is going to give me negative 84. All over 2. X equals negative 8 plus or minus the square root of negative 20. And here we run into an issue. You cannot take the square root of negative 20. There is no pair of numbers that multiply to negative 20 that are real numbers. There is a set of complex numbers that does multiply there, but you cannot multiply a pair of numbers and get negative 20. So in this case, what we do is say there are no roots slash solutions or x-intercepts. If you were to graph this really quick, just looking at this, you can look at a graph as well and say approximately negative 4 and 5 is going to be the vertex. So negative 4 and 5, maybe somewhere over here is our vertex, and it's opening up. So it's going to open upwards. So you can see this graph, this one opens upwards. There is no x-intercepts because it doesn't cross the x-axis. So if you get the situation where you have a negative under the square root sign, then what you have is a case where there are no roots or solutions. Okay, so those are the two cases that you're focused on. You're either going to get something that works under the radical, and you'll be able to break it up into two components and solve it, or you're going to get a negative number, and if you get a negative number under the radical, then you cannot solve it. Do note that there is a case where you might get 0 under the radical. If you get 0 here, the square root of 0 is 0. 0 times 0 is 0. So note that the square root of 0 equals 0. In that case, you'll have something plus 0, something minus 0. It means you only have one x-intercept. It's one of those situations where the graph is bouncing off and touching the x-axis at one point. All right, if we have a short word problem here. Small rocket is launched off a platform. Its height h in feet above the ground t seconds after launch is given by h equals negative 4.9 t squared plus 100 t plus 22. When does the rocket hit the ground? When the rocket hits the ground, that means that the height above the ground is going to be 0. That means our intercepts, in this case t instead of x intercepts, are going to be 0. So it hits the ground when h is 0, or when 4.9 t squared plus 100 t plus 22 is equal to 0. This is not going to be easily factorable. I can already tell because I got a decimal in there, and decimals are hard to work with in these situations. So we're going to use the quadratic formula. In this case, instead of x, I will use a t. T equals negative b, so negative 100 plus or minus the square root of 100 squared minus 4 times a times c all over 2 times a. So I'll work through that. Negative 100 plus or minus the square root of, and I'm just going to calculate that whole portion under the root. 100 squared minus 4 times negative 4.9 times 22 is going to give me 10,431.2, and that is over negative 9.8. All right, now I got to break this up into two parts. T equals negative 100 plus the square root of 10,431.2. You could do the square root first. I just did it. I often leave the square root in there because sometimes we're not going to get a situation where it works out. Or t equals negative 100 minus the square root of 10,431.2 over negative 9.8. So now I'm going to calculate that. I'm just going to throw that in my calculator and get the decimal values. Negative 100 plus square root of 431.2 so I get t equals negative 0.22 approximately, or t equals, and then again plugging all that in. You can do it step by step if you wish. I'm just going to do it all in one great big step in my calculator. Negative 100 minus 10,431.2 divided by negative 9.8. And that's going to get me approximately 20.63. Now, looking at these two answers, when does the rocket hit the ground? Does it hit the ground at negative 22 seconds or at 20.63? Well, if you think about it, we're launching it off a platform. So we're going to have a graph looking like this. We're not going to worry about the negatives in here. So the negative 22 is actually back here after we've launched it and it's come up and down. So this one here, our positive value, is going to be the only one that works. This here is when it hits the ground. So therefore, it hits the ground 20.63 seconds. So that there, in realistic cases, again, you got to pay attention to, does the negative value even matter in the case of the question? All right, now the second part of this question had asked, when is the rocket 10 feet off the ground? Well, looking back at our graph here, you got 22 here. You're going to have somewhere down here is going to be 10 feet. So what we can do is set it up similar to this. When the rocket's 10 feet off the ground, h is going to be 10. So there we have it, h is 10. But the quadratic equation needs this value to be 0. So how do we make that 0? Subtract 10 from both sides. So if I subtract 10 from that side, I can subtract 10 from that side, and I will get negative 4.9 t squared plus 100t plus 12 now. So all I've done is when I want to find a point or points, because it'll give me two answers. One of them in this case is going to be not needed because it's going to be, again, behind our starting value. But it'll give us our two values that are two possibilities, and we can isolate the one that we need. So now I've set this up by setting the y value, or in this case the h value, to what height we're looking for. I'm able to rearrange that, and now I can use the quadratic equation to solve this. So in our case here, t equals negative 100 plus or minus the square root of 100 squared minus 4 times negative 4.9 plus 12, or sorry, times 12 over 2 times negative 4.9. And now I can use that to solve for the value when it is 10 feet off the ground. And again, I am going to just do all the stuff under the radical in one big step. 100 squared minus 4 times negative 4.9 times 12 is going to give me 10,235.2 in this case over negative 9.8. And then I can go about solving that. So I break that up into its two component parts, and then I will solve that. Negative 100 plus the square root of 10,235.2 divided by negative 9.8. T equals negative 0.12. And already I know that's not going to be the answer because it's a negative. So our answer is going to be the second situation here where I have negative 100 minus the square root of 10,235.2 divided by negative 9.8. And that's going to be at 20.53 seconds. So that is my answer as to when it hits when it's 10 feet off the ground. So here is this is the quadratic formula. Again, you need to make sure that whenever you're solving it, you're setting the y value equal to 0. So in the case of just finding the zeros of the equation, like in the first example here, you just go off with the regular equation. In the case where you're trying to find a point where you're not at 0, you set the y value, or in this case it was the h value, equal to that number, rearrange so it is equal to 0, and then you can sub in, and then it's just a matter of using BEDMAS to go through and break that down until you get to the plus minus portion that you have to complete it, and you can break it up into its two component parts.